Welcome back, friends. Let's continue our discussion on algorithmic strategies with dynamic programming and backtracking. Now let's see what is dynamic programming. This is an algorithm design method in which the solution to a problem can be viewed as a result of sequence of decisions. For example, consider the problem of finding the shortest path from source vertex to destination vertex in a directed graph. Here, vertex 1 is the source vertex, while vertex 6 is the destination vertex. So now, from vertex 1, we will move either to 2, 3 or 4. Suppose we decide to move to vertex 3. Then we choose vertex 5 to move from 3 to 6. Thus, the total length of the path is 6 units. Now let's consider another path. Suppose we move from vertex 1 to vertex 3 and then to vertex 4 and finally to vertex 6. Thus, it gives us the path length as 5 units. Another way to reach vertex 6 is 1, 4, 6, which gives path length as 6. So these are the sequence of decisions for finding the shortest path. But the optimal path is 1, 3, 4, 6 among all these sequence of decision. The optimal sequence in dynamic programming can be obtained by using the principle of optimality. The principle states that an optimal sequence of decisions has the property that whatever the initial stage and decision are, the remaining decisions must constitute an optimal decision sequence with regard to the state resulting from the first decision. The only difference between greedy method and dynamic programming is that in greedy method only one decision sequence is ever generated, and in dynamic programming many decision sequences may be generated and the optimal one is selected at the end. Now let's move to another algorithmic strategy, that is backtracking. Backtracking is one of the most general techniques. It is used when there is some degree of uncertainty and the situation unfolds at each step. When we find that we are unable to reach to a final solution at any particular step, we backtrack to the previous steps and start over with another option. Let's see how backtracking works for the 4 queens problem. Here we have to place 4 queens on a 4x4 chessboard so that no two of them are on the same row, same column or diagonal. Let the respective queens be placed on the respective rows. So now, if we place queen 1 on column 1, then queen 2 is placed on column 3, as we cannot place them on same column or diagonal. But further you can see that we can't place queen 3 and 4. So we backtrack to the next position of queen 2 and place it on column 4. Next, queen 3 is placed on column 2. Now observe that we can't place queen 4. So backtrack to queen 3, but it can't be placed anywhere. So we backtrack to queen 2. Here also it is the same. Finally, we backtrack to queen 1 and move it to column 2. Next we place queen 2 on column 4, queen 3 on column 1 and queen 4 on column 3. This is how, using backtracking technique, we have solved the 4 queens problem. So friends, now you know the algorithmic strategies and their applications.